Hello there. Today we'll be doing the longest palindromic substring. Given a string S, return the length of the longest palindromic substring. So the string is going to be 1,000 characters long, and we need to find out where it will be palindromic. So in this example here, example 1, you see Mac Taco Cat book. And the output is 7 because Taco Cat in the middle is the longest palindromic substring. So one way we can already think about immediately is that suppose we take every single item and we expand both ways. Can we find out the palindromic of the maximum length of that palindromic string, right? So for every item. This will take, let's say, O of n times the length of each string, which is O of n as well. So n times n, which is n squared. It will take n squared time for us to expand it to get the correct answer. Another way to do this is to do a dynamic programming question. The way we can think about it is because we are going through like all this is more of a breadth first search. So we found each single character is equal, and we expand and every 2 characters are equal. We expand out from there to get. Furthermore, like we get tries 3 strings from that particular point where it is true, like where it's possible. And if they're equal and the previous item was equal, was a palindromic, and this whole item is palindromic, and we expand that out until the length of the string and get the longest palindromic solution there as well. This will also take n times n time the length of the string times the length of the string. So this is about the same, but if you think about it, if we draw it out for you, let me just grab some tools and give it to you straight. Alright, so open board. So here we go. Let me shrink my screen. So if I give it to you straight, it's gonna kind of look like this. So let's try this. Is 0, 1, 2, 3, 0, 1, 2, 3, and oh, that is not in my vicinity. Sorry about that. So 0, 1, 2, 3. Let's try that again. So I'm gonna find some spot. Let's say right here. 0, 1, 2, 3. Right. 0, 1, 2, 3. Let's say our string is A, B, A, C. Right. So all of them are going to be true if they're a palindromic as a single item. None of these are true if they are a 2 item. So 0, 1, and then BA, and then AC. So these are 0. And then we try for 3 items. So A and A are equal. So then we check the previous item here, which was the 1 of 1B, and it was true. So we can say that, mark that as true, and we can record the max length to be 2, or we can record this particular string. Then otherwise we just look at the next point, and that's also 0 because 1 to 2 back is not a palindrome. And then we do 0 to 2, which is not a palindrome, and that's it. And we save our distance, which is 2, and we return that. So it's about divided by half. And that's about it. So let me, so we're going to do all these 2 solutions, both n squared time. And let's begin with the expanding out method. So this is the pretty basic method. So we're gonna run this I in range length of s. So for every item, we're going to start at that particular item, and for j in range length of s, which is the length of the string how long it can be. So if I minus j is greater than or equal to 0, so like the previous item, and I plus j is less than the length of the string, then this is the maximum item. So if string I minus j does not equal to string I plus j, which is the two items across, break. Otherwise, max length is equal to the max of max length j times 2 plus 1, because we need the extra item in the middle. So one thing I see here is that once this is an else statement, if it's outside of the range, I think we should stop. Just break immediately. And then that's it. So we keep going until the end, and we get to find the max length for a single item. That starts at a single item, but we might have an example where it starts with 2 items, like A, B, B, A. So we don't want to miss that. So we're going to repeat this, but we're going to do a the I plus 1 for our additional test case. So if there's 2 items that are equal, we're going to start checking for them as well. So this is I plus 1, this is the second item, plus j is less than length of s. And if s of I minus j does not equal s of I plus 1 plus j, break. Otherwise, max length equals max of max length j times 2 plus 2 this time. Other than that, we should probably break if any of these are case, and return the max length at the end. Let's run. Looks good. We have an issue. Miss Lengthy is wrong, so this is a typo. And we are good. This is not the fastest solution, but it will do. We can simplify this problem some more by creating a helper function and doing this in a way where we have left right instead. That way we can keep better track of everything. So I'll just shoot this all away, and we'll move on from there. This is going to be a pretty long video. My gosh, I think I'll just finish. Sheesh. Okay, here we go. So we'll set the counter to be equal to 0. And we're going to run the palindrome check. The counter, the start, and the left, and the right. I mean, s is in the string. So while the left is greater than 0, and r is less than the length of s, and s of l is equal to s of r, we can keep going. And we also want to see if right minus length plus 1 is greater than our counter, and so we can update our counter if it's there's a point at which this is greater. Then we return the counter. So let's for I in range of every string item, we're going to start with the odd lengths. So L equals R equals I, and the counter is equal to palindrome check of the counter, the string, and the left and the right item. And then we'll do the left and right items. So we don't have to worry about the error boundaries here if we take care of it later in our helpful function. And once that's complete, we can return the counter. So I think that's perfectly fine. All right, so this was a little faster because of the way we I guess handled the edge cases. So with that out of the way, it's time to move on to the DB problem. This is going to take maybe even 10 minutes, but I think you guys can carry on. All right, let's do it. Let's get it. Let's get it. Okay, so let's create that table. Whoops. Let me comment this out and then push it to the bottom, and let's create that table and let's get started. I hope you guys still remember what we're doing here. If you guys need a quick reminder, let me pull up the board. So remember, whoa, that looks pretty fishy. So we went through A, B, A, C, and we had the true items, singles, and we had doubles, and then we had triples where we had A, B, A, and we found that the previous palindrome B was a palindrome which was true, and we set that as our new palindrome. Okay, so let's get to it. So string set our results equals false times n for I in range n. So number of times we create these false. So n is the length of the string, so we create that many falses in one array, and then we create that many of arrays of that type false. So let's get to it. So let's set that as our start and end of our longest palindromic substring so far, and let's go set every single one character, so that one diagonal line. Okay, let's get to it. So the I item is all the diagonal lines, and set that to true. And for I in range n minus 1, this is we're gonna set the two items. So so if AB, BA, and BC is equal to, AC is equal to each other. So we're gonna have to set those first. These are our base cases. And if not X and not Y, we're gonna reset our our longest substring. So once that's complete, we're going to go through our last step, which is to go through each particular length, starting from 2 all the way to the end of the string, the length of the string, and we're going to do that for every single character that gets to that point. So for k in range 2 and n, I in range n minus 2, j equals I plus k. This is the location of the string adding given the distance way. So there's basically a, b, a, and this is that a adding the distance. So if j is equal to the distance of the string, so the length, we can just call it quits there. So let's get to it. All right. So right, where are we? So we're gonna look at the if results I plus 1 and j minus 1. This is one row down and one column back, and s of I is equal to s of j. That means they are equal. That means we're going to set our results I and j to be true, and then I will update the length of the longest subsequence if it is equal. Substring if it's equal to the new length. So now we're gonna return the length of our string from that distance, and we can also get the actual string itself. Let's see if something's wrong. So here, what could be wrong? Oh, we're missing a bracket. Another something wrong. Invalid syntax. Let's see. Line 11. And this is not a for loop. This is if. Run. Submit. Oh, results is not defined. That is line 12. Run. Submit. Alright, so the DP solution is actually a little bit slower than the other solution. But I hope you found something interesting here. Any questions or comments, please list them below. I will do my best to answer them. If you enjoyed the video, please like and subscribe, and look in the link in the description. Look into the description below to find my links for more algos. You can also find where the sources where I found these very good solutions. The first solution was mine in this case for this problem. The other two were found elsewhere. I'll link you to those solutions, and yeah, have a good one.